We'll prompt for the file name, input, enter file, colon, space. Now I'm going to do something. If the length of the f name that I just read is less than 1, I'm going to say fname equals clown.txt. I do this so that I can just hit enter and it defaults to clown.txt. If I want to give it a different name, I can. So this, if I just hit enter at this prompt, then this will give me a string that's 0 length. So if it's less than 1, I'll just assume that. So let me open that. Handle equals open fname. And let's read through it. For line in handle, we'll strip it. Line equals line.rstrip to take the white space off the right hand side, and then we're going to say print line. Again, I'm not just doing this. When I write code, I just saved it. When I write code, I do these kind of stuff all the time just for my own sanity checking. And so now I'm going to run Python 3 ex09.py just to test that. I'm going to hit enter now, and it's going to assume hopefully clown.txt if it all goes well. And yep, it read one line. Okay, so that part's working. I'll just leave that print statement in. The next thing I want to do is kind of a classic thing where we're going to go read a bunch of lines and then go horizontally across those lines in words. So I'm going to split that. WDS equals line dot split and print WDS. So I'll print that, and I'm going to save it and test it. I really love to test things over and over. There's the actual line. This file, clown.txt, only has one line, and it breaks it into words, and so I have those words. Let's just run it again with intro.txt. So this will have a lot of lines, line, lots of lines. Every line prints out the line and then prints out the words that we split it into. Okay, so now one of the things that I do here is I want to believe, now I sort of can believe everything from here up. Like, oh, it's going to open the file, it's going to read through the lines and going to split them into words. And so then I'll just kind of behind it, I'll just say, okay, I'll just comment that out. Now I need another for loop for W in WDS. Now words is a Python list and has some number of words in it, 0 or 12 or whatever was on the line. And now I'm going to print out the word. Okay, and so now it will go through that horizontally. Now I'll just do clown.txt so that you see I'm not printing the line out. That's the words that have been parsed split from the line. And now we got this loop. Now, one of the things that's interesting is just to make sure that you're going through all the words. And I like a print statement here to know that W is going to successively take on literally all the words of this file. So if I comment this print statement out and I run it again, clown.txt, that for loop starting from here is every word in that file, which happens to only be one line. But now if I do the same thing for intro.txt, it's just going to go through the words. And in a sense, by nesting these two loops, we're going to hit all the lines. And that's a lot of stuff, but it hit all of the lines, all the words, and away we go. Okay, so here's where a dictionary comes in. I'm going to make a variable called di for dictionary, and I'm going to say give me a dictionary. Now dict is not something you can choose. That's saying that's defining the type of dictionary. Di is a variable that I chose. Okay, so the key thing to this dictionary is we're going to make a counter, and we're going to use W, the word, absorb, elegant, whatever, and we're going to use that as the index. So the simple thing to do is to say if W is in di, then we can say the dictionary sub the word, which is our key and the key value store of the dictionary, is equal to the value that we had before in that area, d sub w, plus 1. And if it's not in there, else di sub w equals 1. And I'm going to print print new. So every time we see a new word, it's going to say new. And I'm going to also then print w and the current value of the counter for w as it's going through. Now notice how far in I'm indented. This is all part of this inner loop. So this is the loop that's going to run every single word. Okay? And I'm going to run this first with clown. So it runs slowly. Okay, so we saw the was new. And the count is 1. Clown is new. Count is 1. Ran is new. The count is 1. After is new. The count is 1. Now we saw the again, but now we made the count be 2. Let's print here. I'll say existing. So you can kind of see it. Now in the print, I'm printing this. Let's make it even a little more verbose. Print w. And then I will make it so it prints the word before and the count after, and then whether it's existing or new. So we're put a lot of print statements in. Print statements are cheap. Okay, so now we see the word the. It's the first time we see it, and we set it to 1. We see the clown. It's the first time we see it, we set it to 1. We see ran, new, 1. Later on, we see the. It's already in. So existing means it was already in the dictionary. W as a key was already in the dictionary. Okay, and so that's why we added 1 to it. So the old value was 1, and then we added di sub the equals di sub the equals di sub the plus 1. W is the string the, the. That's what that string is. Okay, and so we've made it all the way through, and you see the in this one line occurred ultimately 7 times. So now I want to print out the contents of this dictionary at the very end of both loops. So I got to de-indent twice, and so that will give us the counts. And so this is what we get when it's all said and done. You know, the happened 7 times, but it just worked through its way through. Okay? So you got that. Now, this is a pretty verbose way of doing this, but I did it sort of the slow way to show that there are 2 situations. If it's already there, you increment it, and if it's not there, you set it to 1, effectively inserting it, right? So you insert it and set it to 1 with this di sub the equals 1. Okay? But let's get a little less verbose here, get rid of some of these print statements because we kind of covered all that. Get rid of this line and go back to printing w and diw at the end. We'll leave that one in. So what I want to do is I want to look at this bit of code right here, this if w in di else. We do this so much with dictionaries that there is an easy mechanism to do this that combines these 4 lines into a single kind of contraction. And so I'm going to do this. I'm going to print, let's put 2 stars out, then the word and di.get of the word, comma, negative 99. Okay, and so this di.get of the word is the important part. The way it is this is a dictionary. .get says in its first parameter is the key to look up, which is word like the or fell or clown or whatever, and 99 is the default value that we get if the key doesn't exist. So this is in effect an if then else, right? This little di.get w99 negative 99 is, you know, if it's in there, do one thing. If it's not in there, do something else. Okay, so let me show you how this works, and you'll see that the 99 will happen when Okay, so the first time we see the, get returns 99. Right, so let's move it over here. The first time we see the is not in the dictionary. So this di.get of the word the in the dictionary gives us back the negative 99. Okay, and this still is working, and so the is 1, clown is whatever, but away we go. Okay, let's do it this way. Let me comment this out. Let me comment this one out and run it again so it's a little clearer what's going on. Okay, so the first time we see the is not in the dictionary. The first time we see clown, and we know it's negative 99. But here we asked for it, and the is 1 because we'd seen it before. And so that's just this get mechanism allows us to get the new value, or get a value out if the key exists, and specify a default if it's not there. So I'm going to go old count equals di.get w comma 90 comma 0. So instead of using 99 here, I'm going to just get rid of all this. Is what I'm saying is look up in this dictionary. Get is a function that's part of all dictionaries. Look up using the key w, which is the, and if I don't get it, give me back 0. And so I'm going to say print word, comma, old, comma, old count. And now what I can say, whatever the old count is, it's either the value that was in there or 0. And now I can say new count equals old count and now, let's see, new count, and I can say dictionary sub word is equal to new count. So instead, I'm going to get rid of this if then else then. This is basically saying look up the old count that we have. If you don't find one, use a 0. We'll print that out. And then I'm going to say afterwards, I'll print the new count. Now, and so we'll print the old count. Here are some of these blanks. Print the old count. And you can see the old count with the, because the doesn't exist, was 0. The new one's 1. Clown's old is 0. New is 1. Clown's old ran old 0. But now we get to the, its old count was 1, and now its new count is 2. Okay? So by using this get and saying if we don't find it, we'll assume the count is 0. That makes a lot of sense, right? You know, if not there, the count is 0. If the key is not there, the count is 0. Okay? So that's what this line does. If get the value from under the key associated with the key, or give me 0 back. And then I can take that old number and just add 1 to it and then stick it back in. Now this is ultimately not how we tend to do it. Okay? We tend to blend this all into one big long statement. di sub w equals this part plus 1. Okay, so that says get the old value from this key or 0 and then add 1 to it, because that really combines all of these lines into a single line. Okay, so I'm going to delete them now. And now we've combined this all into one, what effectively is an idiom. Retrieve, create, update, counter, all in one line. I'll still print out, in this case I'll just say di sub w and then we'll see the counter. Okay, and so now I'll run this. We have a new, but now we see it the second time it's 2, and so we see car the first time, we see that the second time, we see car, the third time, we see car the second time, and away we go. Okay, and so that's pretty straightforward, and so it really kind of a typo there. So let's just get rid of that and run it with the clown stuff, and we get the right data there. And let's run it with intro.txt. And there we go. Okay? And so it's tearing out a bunch of words and giving us a dictionary. So that was a lot of work to get to this line 16 that has the dictionary in it. Now we want to find the most common word. And so we're going to loop through this dictionary, and part of it is like, once we've printed this dictionary out and we verified that it's right, don't worry too much about the code up here, right? Matter of fact, I can take out some of these print statements, and we can kind of trust all this. And so now we're going to work on this. Okay, now we want to find the most common word. Now this is like a maximum loop. So if you recall, we have a whole set of key value pairs. Communicate goes to 2, is to 2. Skills is 3. So we have these key value pairs, and we're going to loop through and look for the maximum. Now, in a dictionary, we can loop through the key value pairs with the following syntax. For, I would call these variables k and v for key and value, but in the dictionary's name dot items. And items is a method inside of all dictionaries that says give me the key value pairs, and we need 2 iteration variables. So this is like an assignment statement for k and v. K and v take on the successive values for the keys, the key and the value. Okay? So if I just now print k comma v, and I'll take this print statement out and then run the code on, oops, what I forgot to, oh, I fell back into my Python 2 days. Need parentheses for my print. So there's clown, and it just prints it out. And it's kind of the same thing, except it's pretty, where we're putting each one on a line. Okay, so the v is the value. So we're looking for the largest value. Oops. So the thing is, we know that the values are always numbers that are greater than 1. So I'm gonna do kind of a quickie maximum loop. Largest equals -1. Now in previous times we've seen that this is a bad assumption, but because we know these are counters that are always positive, it turns out this is not a bad idea. And so I can say if the value is greater than the largest we've seen so far, largest equals the value. Okay, and when that loop is all done, we can print the largest. Okay, and so this is just a max loop, and we're using this value. That's the number. The value is the second thing. Oops. Can't type Python. Oh, it's a typo. Yeah, I'm not using value, I'm using v. So largest equals v. Let's try it again. Okay, so we're all done with 7. So these were the things that we were looking for, and it was looking for the maximum, and it just dutifully found 7 was the largest. But we also want to know what the word is. And so what we can say here is we can say the word is none, meaning it's just like we don't know what the word is. And then whenever we catch this new largest number, we say the word equals W. So I like to think of this as capture, remember the word that was largest. Right? That's what I'm doing. Remem, E-M, remember. Right? That's tough. R-E-M-E-M-B-E-R. There we go. So we're gonna this trick here is not only knowing what the largest number was, but the word that was associated with the largest number. So now I can print out at the end the word and the largest, and that's the count. Okay, and so now we know that. Oops, did we make a mistake here? Okay, that does not look good because it says car and 7. If V is greater than the largest, oh, it's not W. I used a really bad variable. See, that's the old value there. There we go. It's K, which is the key. Key. I was going to say that was quite the bug. See what happened there? I had this as W, and it just happened to be it was the last word on the file. Car, the last word in the file, because I used a wrong variable. Right? No, little mistakes, little mistakes. The and 7. Okay, so let's get rid of this print statement because we kind of know what's going on here. And away we go, and this should now work if we run it. We can even get rid of the word done here. There we go, the 7. Now, the cool thing about this is this code runs just as easily with one line of code or the intro of the book, intro.txt, and not surprisingly, the is still the most common word in the introduction.txt. I seem to like that word, and it's 226 times. Okay, and so that is the basic pattern of reading some. This is just a word loop. Now, sometimes there would be some, checking to see if the line is the one you're interested in, maybe tearing apart the line, but it's at the end of the day, this idiom of starting a dictionary. Now, it's a common problem to know where to start the dictionary. You want to accumulate the numbers for the whole file, so you don't want to put it in between line 6 and line 7. Okay? So I hope that particular thing helps a little bit, helps you understand dictionaries. Hello and welcome to Chapter 10. Now we're going to talk about our third kind of collection called tuples. But tuples are really a lot like lists. There's not too much to them. They're really kind of reductionist version of lists. They're so they function very much like lists in that they have things, and the difference is there are no square braces. There is a parenthesis, round brace or whatever, and they have positions 0, 1, and 2, just like a list. And you can look things up, x sub 2. So x sub 2 is actually the third element here, and so that prints out Joseph. You can assign, make a tuple here. This is the constant syntax for a tuple, and print that out, and the print statement shows you that this is a tuple, not a list, by showing you round parentheses. And a whole bunch of functions that work with lists work the same way with tuples. You can put a tuple at the end of an in statement in a for, as you might expect, and then it iterates through the tuples. Tuples maintain order, so it prints out 1, 9, and 2. So literally this bit of code here could be identical whether it was a list or a tuple. It really would do the exact same thing. The difference between tuples are that they are immutable. Once you create the tuple, you can only sort of assign a tuple, but you can't modify it. You can modify a list. So if we take a look at a list here, we make a list that's 987, and we say x sub 2 equals 6, well, that just means this 7 becomes a 6, and that's just natural, meaning we can reassign slots. We can delete things, we can insert things, we can mutate them, we can change them, so they're changeable. Right? They're changeable. But if we try to do that same thing with a string, So we say y equals ABC, and we know that this is position 0, 1, and 2, but if we try to say, let's change the C to a D by saying y sub 2 equals D, that is not allowed. And it says it doesn't support item assignment, and this little bracket, x sub 2 is what they call item assignment inside of Python. And so if we do the same thing then with a 3-element tuple, put that in Z, and we try to change this slot to be a 0, it's going to blow up because it's the exact same thing. And that has to do with the fact that once this assignment is made, this is not modifiable. Now, it turns out that the reason it's not modifiable is for efficiency. They take up less storage, they are quicker to access, and they're really designed internally behind the scenes in ways we don't really need to understand. They're just more efficient than lists. If all you want to do is store a list and look at it and then throw it away, you probably should use a tuple instead. So there's a lot of things that you can do with lists that you also can't do with tuples, but they're really just a corollary of this notion of non-mutability. And so, like, you can sort a list, but you can't sort tuples. You can add a 5 to the end of 3, 2, 1. Can't do that in a tuple, but you can in a list. And flip the order. ... So anything that you can do to a list that modifies the list, not allowed for tuples. And so you can take a look at the kinds of things that are inside, the methods that are part of each list: append, count, extend, index, insert, pop. Many of these are modifying, and then count and index are the only ones that work for tuples. And so tuples are limited lists. Now, at some point, there's going to be a but here to say, why do we like them? And the reason that we like them is that they're just more efficient. They don't have to build Python in its own internal organization of these objects. It knows that they'll never be modified, because when you make a tuple, you as the programmer are saying, I'm never going to modify this, and Python won't let you do it. So it's higher performance, better memory use, and to a beginning programmer that doesn't really matter, but that's the reason. And so we tend to use tuples when in situations where we're going to make a temporary variable and then temporarily use it just a little bit and then throw it away without really messing with it. And we tend to use lists to build things up, etc., etc., etc. So the other thing that's interesting about tuples, and we've actually sort of seen this, is that you can put a tuple that includes variables on the left side of the assignment. And this takes a little getting used to, but it's really cool, and no other language that I know of does this. So if we say x comma y, that's a 2-tuple. Both have to be variables. You can't put constants on this side. It's like saying x equals 4, y equals Fred, right? So what happens is you can put a tuple on the far side of an assignment statement, and the 4 goes to x, and the Fred goes to y. And you say, what's in y? Well, y is indeed Fred. And so this is like 2 assignment statements. Now, the way I've got this syntax, I would probably do, 2 separate statements, just not to show off that I know how to do tuples. And so here's another one, and they just move correspondingly. If you don't have 2 here, and you do have 2 here, well, if you have 3 here, or 2 here and 3 here, and you don't match the number there, you get in some trouble. Now, if you just say x equals tuple, then that is the tuple in the list. But this is just a simple straight 99 value going into A. So you can put tuples as the left-hand side, and you can even do things like return a tuple from functions. That's a real nice Python feature that I like a lot. Tuples are also related to dictionaries, as we've seen in the previous chapter. So here we make a little dictionary. We make an empty dictionary by constructing an empty dictionary, stick it in D. So D is sort of like this place that can hold key value pairs. And we put csev, and there's a 2 in there, and chen1, and there's a 4 in there. So we have this, associative mapping between csev 2 and chen1 and 4, all stuff we know. And now we say, hey, we're going to loop through the key value pairs here, and we've seen this syntax before, k comma v. So this is a tuple. So you can think of this as each one of these things is going to get assigned into this tuple, which means the key ends up and the first one's the key and the second one's the value. I use the variable key kv all the time in code that I write, just for my own sanity. So kv are going to iterate successively through the successive keys and values in that. So this is going to run twice, and k is going to be csev 2 and chen1 4. The order just happened to stay the same. And so if you say what is in one of these things, you can actually take D items, the items method within that dictionary, and say, hey, give that to me back, and then print tups. And it's a special kind of a class, but really ultimately it is a list of tuples. This is 2, this is the 0, and this is the 2, the 1, the first and the second. And then within each thing you get, you have a 2 tuple. And so, in a sense, this K and V are iterating through those things when we're putting D items here and D items there. One nice thing about tuples is that they're comparable. They're comparable in the same way that strings are comparable, meaning that they're compared from left to right, with the leftmost or 0 tuple being the most significant. And it doesn't compare any further than it has to if it's asking less than. So if it's looking at, say, this first tuple, it starts at the left and says, okay, ask the question, tell me true or false. Is 0 less than 5? The answer is true. And so the answer to this overall expression is true, and it doesn't even compare those two numbers, those second and third number. They don't compare them. If, on the other hand, we're asking, is this less than that, it only looks at the first one and asks if it can answer the question. And the answer is, well, they're both 0. And so I can't answer the question, so I have to go to the second one, second pair, and 1 is less than 3, and so that means this is true. And it does not check this. Even though 20 million is bigger than 4, it doesn't matter, because these are the numbers that cause the true to happen. And the same is true if you do this with strings. Again, we start the first one, so Jones, Sally, well, that's the same, so we don't know the answer yet. And so Sally, Sam, well, okay, S, oh, they're the same. A, they're the same. O, L, and M. L is less than M, so the actual letter that makes the difference here is the L and the M, and leads to us being true. And so it goes left to right, but then even when it's doing strings, it's going left to right. That's just how string comparison works. And if we say is Jones, Sally greater than Adam, Sam, well, we check the first one, and we check the J and the A. Well, J is greater than A, and so we don't have to look at anything else. We don't have to look at any more of these characters. We don't have to look at the second thing in the tuple. We have to look at that is enough to be true. So it only scans until it has a definitive answer. It doesn't scan any further. So now what we're going to do is use this comparable capability to sort these lists of tuples, and then bring this all back and connect it more to dictionaries. So now we can take advantage of the notion of comparing tuples and use sorting. And so what we're going to produce is a list of tuples, and then we're going to sort them, right? And so we can get a list of tuples from a dictionary, and then we can sort that list of tuples, and then we can end up sorting dictionary items by taking this two-step process. Convert dictionary to a list, sort the list, and then we can have assorted dictionary values. Okay? And so we'll do this a couple of different times. So if we take a look at this code right here, we have our happy little dictionary, A, B, C, A maps to 10, B maps to 1, C maps to 20. Like, what are we going to get here? Well, it comes out, the mapping is the right way, but the order is whatever. And now we say this function called sorted, which takes inside a sequence and then returns us a sorted version of that, a list that's sorted. And so it says sort D items. So it's basically going to take this list and compare the A's and the C's and the B's, and because it's a dictionary and all the keys are unique, there's never going to be equality, so it really is going to just sort this by keys and never get to looking at the values. You could construct a list that had duplicate, you could make a list of tuples that had duplicates in the first, like we did before, but given that this coming from a dictionary, the first thing is going to always be unique and distinct. And so if we say sorted D of items, that we're passing this stuff into sorted. Sorted is going to go around, move stuff around, and then give us back a sorted version, sorted in ascending order based on key, without looking at the value. And so that's a way to see dictionaries sorted by key, is just say sorted of D sub items. And sorted is a function, and so it just picks stuff. And so this is the kind of loop that you're going to write to do that. You know, we did this before. We took sorted and we got these sorted by keys. And so you can just make this nice and simple for key value. By the way, you can eliminate the parentheses here, and I think it's prettier if you eliminate the parentheses, but you could put parentheses. This is still a tuple without the parentheses. For key and value in sorted. So that says go through D items, but before I go through them, please sort them. So that means K is going to go through A, B, and C deterministically every single time it's going to go. And of course, value is going to go through the corresponding values. So now we can print this out nicely, sorted by key. And that's a real nice, succinct little way to say that. I mean, again, these are one of the kind of things that people really like about Python, is that you can do pretty powerful things with easy to understand. I mean, you might have seen this for the first time, but ultimately you look at that eventually and you're like, oh yeah, I see exactly what that's doing. Easy, not hard at all. So, but let's say we're looking for the most common word, which we have been for weeks and weeks and weeks now. And so we want to sort by values, not key. So this is an example of where we're going to construct a data structure. We're going to imagine a data structure, and then we're going to write code to construct the data structure, and then that's going to make our problem easy. So this is an example of using cleverly constructed data structures to do this. And the data structure that we're going to create is a list of tuples where the value is first and the key is second. So you can just with items get key value. I want value key. So let's take a look at this code. Take your time and get it right. So KV goes in C items. Well, that is unsorted and going to go through whatever A, B, and C in whatever order. And we're going to make a new list. So this is a data structure that we're creating temporarily. And what we're going to do is, this is a list. And we are going to append to that list a tuple. So this is going to be a list of tuples. Except we're not going to append them in key value order. We're going to flip them and append the first part of the tuple is going to be the value and the second part is going to be the key. So we end up with this. This is sort of our temporary data structure that we have constructed to make our job really easy. So this ends up being 10A, 22C, 1B. Now we just kind of flipped them. We took this order and then we flipped them around. And so now we have this nice little list sitting in memory in a variable. And that's really simple. We can say, oh, look, we can use sorted. And we can sort by now the values because they're the first thing. I mean, the sorted doesn't know that they're how we produce this list. It just looks at that and says, oh, that's a list of tuples. I'm going to always sort by looking at the first item in any tuple. And I'm going to add reverse equals true so I get a descending sort. So I see that the value that is highest ends up being first. And so that changes this, and I'm just sort it and then reassign it back into temp. And I'll print this out, and so now you see it's sorted in descending order of key. So it's value, key, value, key, value, key, but it's sorted in descending order. Okay? And so that's an example sort of just like, if I just made a data structure and I flipped those things around, I could use sorted to sort these things. There's many other ways you could do it, but there's sort of like the more elegant way of doing it. And the clever bit here is like make a new list and make it be a little bit different. Okay? So here we're going to print out the top 10 most common words in a file. And most of this code is review. So if we take a look at it, we're going to open a file. We're going to start a dictionary for our counting. We're going to, there's going to be words and lines. Right? And so we're going to have a for loop. This for loop is going to go through each line. And then, of course, we're going to split them, which is busting them into pieces. And then we have a for loop within that. And this for loop is going to go through each word. And so that means that by nesting these loops, we're going through each line. And then within the line, we're going through a word. Then we go to the next line and go through the words. And eventually, this line of code, count subword equals counts.getWord 0 plus 1, our idiom for making a histogram. Right? This line right here is an idiom. If you don't know already what that is, go back to the previous dictionary lecture and understand it, because you're just going to use it over and over again. So now at this point, and I always like drawing horizontal lines in code when we write it. At this point, coming through at this point, counts is right. Counts is the histogram. It's not sorted. So now we want to sort it. So we're going to make a new list. We're going to loop through key value. And then we're going to make a tuple. I'm making this be 2 lines to make it a little easier. Value key, so I'm flipping it, right? So I'm flipping the order of these things. That's making a tuple, and then I'm appending that tuple to the list. Okay? So at the end of this, we have a list of tuples in value key order, VK, VK, right? So at this point, coming through here, I've got in my LST variable, I've got this really useful bit of code or useful bit of data that I produced. And then I'm like, oh, now it's ready to be sorted. Poof, sort. So take list, sort it back, and sort it in descending order, and then stick that back in list. Now we want to print it out, but we don't want to print it out. So we got a nice sorted list coming down here. We don't want to print it out in value key, because that's what it is. It's in parentheses V comma K order, but it's sorted. And we know that the highest value is here on down. And so we're going to say, you know, we're going to run through, and now we're going to go through this new list, only the first 10, start at the beginning up to but not including number 10, which is the first 10. For value key in, and so value is good. So this is the iteration variable that's going to go through each of these things on and down, and then we're just going to print it out flipping it. So we re-flip it, flip, flip. We print it out key value, and it's going to work. Okay, so that is one way of doing this, and this slide right here you absolutely do not need to figure out. But some of you will look at this slide and you're like, why didn't you show us that in the beginning? And others of you will be like, no, 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 keep telling me this stuff here. So I don't know exactly the term for this, but this is a very procedural. This is a classic algorithms and data structures approach to solving this problem. This next thing uses what are called lambdas, and they kind of create what's called what I call a closed form, where you kind of do it in all one statement, and there's all this implicit stuff going on. So if you don't get this right away, don't worry too much about that. But roughly, this single line does everything that bottom half of that program does. I mean, if we go back to here, it's pretty much this line does everything, does that in one line. Okay, it doesn't create the counts and it doesn't print out the top 10, but it does everything in that middle bit. So let's take a look at this. So we all are going to collapse this down. So we have a print, that parentheses the end of the print. And then we have sorted, and remember that sorted takes as input a list. And so that's not too bad, and returns us a list. And so we'll print the return from sorted. And then this is the funny part. The fun part, funny part. This is called list comprehension. And we have square brackets, and we say to Python, this is a list. But instead of listing the things or having a constant of 1, 2, 3, or append, 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 we are going to create an expression that will act as a generator for all the elements. And so this basically says, this is a list of two tuples, v and k, and then this is sort of implied. For all kv in c.items. And so this is like a for loop that is sort of driving this. Think of this as like stamp, 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 stamp. However many times it has to make a stamp. And so that's producing a list, right? It just manufactures this list. And then that list is sort of manufactured in the moment. There's no stock, it's not put in a variable. Python makes that list according to the stamping pattern that you've told it to stamp out this list, and then it passes that stamped out list without even storing it in a variable into sorted. Sorted moves the list around because it is just a list of tuples, and then gives us back the sorted list. And so I didn't put reverse equals true on here, but you see that this is sorted in ascending order now by key. And I did that all in one little statement. So look at this. This is also one of the beautiful things about Python, that you can build these things, and you can build more complex versions of this, and there's a lot of real elegant things that you can do in Python. They're really succinct. You should be careful, because in the beginning I think this is easier to understand, even though after a while you're like, wait a sec, why am I putting all these extra lines in? Because this is not so hard to understand, but at some point, you will want to master this more powerful and more succinct version of Python that expresses it in terms of what the data you want to see rather than the steps you want to take. So this sort of finishes up tuples. We've done a bunch of stuff. I mean, really, they're simple and elegant. Tuples, lists, and dictionaries are all related. They're really three different, three foundational data structures, three foundational collections of Python. And we combine those in a lot of different ways. And now in this little bit of lesson we're going to talk about some tuples, and we're going to create a list of the most common words and find out how to sort a dictionary by the values instead of by the key. We're going to use the clown.txt file and the intro.txt file. And I'm going to start with the code from exercise 9 that I just did from chapter 9. It's not exactly one of the exercises, but it's very similar to them. And I'm going to make a copy, and I'm going to keep it in the same folder. I'm going to keep it in the EX09 folder and just call it EX10, because this code is going to do much of the same stuff, and it's going to read these same files. And so I've got myself exercise 10. Exercise 9 is still here. Exercise 10 is now what I'm editing, exercise 10. But I'm in the exercise 9 folder. So in exercise 9, we look for the most common word, but we want to find the 5 most common words, which is going to require us to sort. So I'm going to get rid of that code because it's not really how we're going to do it. There we manually looped through it and found the maximum. And so I'm going to just run this. cd desktop python for everybody ex09. And if I do an ls, you see that I've got ex09.py, intro.txt. So I'll run python 3. ex10.py and run the clown data, and we see the dictionary, and it's properly making it in this code right here. That doesn't change. It reads the file, reads all the lines, goes through and splits it into words, and then goes through the words and does the idiom of using dictionary get to maintain the counters, and we print it out at the very end. So the new code we're going to write is down here. Okay? So let's first do a few things. If I can say x is equal to the dictionary dot items, and this gives us basically a list, print x. This gives us a list of the key value pairs. This prints out the dictionary, but if we do it this way and use items, it gives us the key value pairs. Okay, and so that's what we got. Key value pairs. Now, we can sort this based on the value, because tuples can be compared. This can be compared with this, and because D is lower than R, then this one is lower. This ran tuple comes after the down tuple. So we can sort this whole thing. And I'll do this by just putting the word sorted here and say, give me a sorted version of that. Now it's going to do it based on the order of the tuples. This is going to be higher precedence than this. So if I print it this way, run it again, you'll see that it's sorted. And now is after and car, it's in alphabetical order by key. And so we could actually print the first 5 up to but not including 5 by adding a list on the slice, a list slice here. And so that will show you only the first 5, right? Except that that's not what we're trying to do. We really want to sort by this. Okay? So, we have this mechanism that can take a list and sort it based on the tuple values. If we could create a list where it was 1 comma after instead of after comma 1 and make it the exact same thing, then we could actually then sort it and it would be fine. Okay? So let me show you a couple of ways, at least one way to do that. Okay? Get rid of this. We're going to hand construct a list, and just call it temp equals, give me a new list, temp equals new list, and then for k comma v in the dictionary.items, and I'll just start by printing k comma v, so we see, and this is where it's really nice to do these with the clown code first and then only do your test on the bigger file later. And so it's pretty much the same thing. We are going through in key value order, which is dictionary order, which is not sorted at all. Okay. Now, instead of printing this out, we are going to, let me do this in a couple of steps. Make a new tuple, and I'll just call it newt equals parenthesis v comma k. Okay, so this is, I'm saying make a new tuple. This is like a new tuple with 2 items in it, and I'm going to make the value for and the key, the key. Okay, so Then I'm going to say temp.append new tuple. So I'm going to end up with a list of tuples. Let me comment this one out, and I'm going to then, when I'm done here, I'm going to print temp. So if I run clown.txt, you see what happens in temp. It's still, well, let's print temp twice. I mean, it's not sorted, it's flipped. Let's print it. Well, that's okay. That's the flipped one. Okay, so it's flipped, and all we did is we made it, instead of car comma 3, it's 3 comma car. But now we have a list. Okay, so now it's flipped, and now we can sort that. We can say temp equals sorted temp. So it says takes temp and sort it and give it back to me, and now I'm going to say print sorted comma temp. Okay, so here's the first print. When we flipped it, we've got 210, but it's not sorted at all. But after we sorted it, it's sorted by tuple, and the lowest is 1 after, so you'll notice that 1 is the same as 1, so it checked the second item in the tuple, so down comes before after. Fell becomes after down. Intro, on, alphabetical order, but now we get the 2's, so that all the 1's sort there, and then the 2's come here, but then within the 2's it's sort in alphabetical order, because like a string, if the first character matches, then it looks to the second character, and then we see, oh, here we go, the 3's, and then the one we actually wanted, the highest one, is the 7. And so one of the things we can do is we can say, you'll notice that we want the highest one, not the lowest one. So we can just tell this with this parameter, reverse equals true. And we just say, hey, sorted, do this backwards. Do it from highest to lowest rather than lowest to highest. And now our sorted one says 7, the, etc. Okay? And so if we want the first 5, we can say up to, but not including 5. So this is now the top 5. So the sorted one that's the top 5. If it's a tie, we're going to go in reverse alphabetical order, but let's not worry about that too much for now. So it makes a flipped list, then it sorts the flipped list. Now, if I just wanted to print it out nicer, I could loop through this new list. I could say for v comma k. Remember, this is a flipped list, so the sensible thing is what's coming out of this list. Each tuple is value comma key in temp, and I'm only going to go up through, but not including 5. So the first 5, and so I'm pulling them back out as value key because that's what they are. They're value key. See, value key, value key, value key. So v is going to go through these, and k is going to go through these, and then I'm just going to print k comma v. So this is kind of my flipping backwards because I want to see them this way. And thus the most common one, car 3. And so it's just going through this up through the 5th one and then printing them out. Okay? So let me comment this out. Let me comment that out. Let me just delete this. So we have a dictionary. Let me comment out the dictionary. We have a dictionary, we make a list, and we make these reversed tuples where we have the value first and the key second. We're setting it up so the sort's going to work. And then once it's sorted, we have to flip them back. So we flip them for sorting from key value to value key for sorting. We do the sort, then we flip them back with key value and print them out. And it works fine. So let's try our big file, intro.txt, and there you go. Those are the 5 most common words in intro.txt. So you might ask yourself, why did we use tuples? We could have really used lists for this, but tuples are more efficient than lists, and you notice that we weren't going to modify. We did modify the temp list. It's a list of tuples, but the tuples within the list we weren't going to modify. And so we tend not to make lists if we can get away with using tuples. And so that's why we made this this flipped tuple thing. Okay, so I hope that was useful to you. Hope to see you on the net.
Hello and welcome to Chapter 11, Regular Expressions. The fun thing about this chapter is, unlike all the rest of the chapters, you sort of had to really understand every single thing in chapters 1 through 11 built on one another, 1 through 10 built on one another, but you can really get along without using Chapter 11. It's not a really required topic, but it's a fun topic and an interesting topic. So you can relax a little bit and realize that you may or may not like regular expressions, and if you don't like them, that's okay. You don't have to use them. You can go for your whole life without using regular expressions. The idea of a regular expression is that you come up with a language. It's a little character-based programming language where you can do smart searching, basically. Smart searching, and as you'll see in a bit, was smart extraction, and it's really almost programmable wildcard expressions. There's no looping, but there is looping, and there's all this implicit thing, and you say, look for patterns that look like this, and then you get back things that match those patterns. You know, we do searching for everything. We're looking through large blocks of text, say, go find me everything that has the word Python in it, or something like that. So that's just such a common thing to do, and regular expressions are a very structured way to go about searching for information. They're very powerful, but they're also very cryptic, and you may not like them, but they're a lot of fun, actually, once you understand them. Learning how to program them takes a while. Writing good regular expression programs requires some try it, play with it, check it, try it, check it, try it, check it. But once you get them, they're really quite cool. It's a very old programming language. You know, it comes almost from the 1960s. The concept of, it's the theory of computing, where they were trying to come up with theory of languages, and regular expressions was one form of languages that computers could understand. And so it has some fun old words. And one of the advantages of knowing regular expressions is that you're kind of a cool person. You can take a quick look at this XKCD that sort of captures the devil may care awesome power that regular expressions do. And while we're at it, while we're talking about awesome, I do want to take this moment and show you my awesome tattoos. And so you may not know this, but I got a couple tattoos here. Here's the first tattoo. This is where I got my PhD, and this is my University of Michigan faculty member position. I got PhD in engineering, and I teach in a school of information and library science. And then I have this other tattoo, and this tattoo is what I call the Ring of Compliance. I work on learning management systems and educational technology and standards, and there's this standard called Learning Tools Interoperability, which if you're using this course and doing the AutoGrader, it uses Learning Tools Interoperability to integrate into whatever learning management system you happen to be using. And one of those learning management systems is the open source learning management system that I helped write called Sakai. And these are the rest of the major vendors. And the idea of that tattoo was that I would put the tattoo of every vendor that would comply with Learning Tools Interoperability. And so you'll notice Coursera. I helped Coursera put Learning Tools Interoperability in. And so the AutoGraders integrate into Coursera or Blackboard or Canvas or Sakai or Moodle or half a dozen other things. So it's just like a cool techno thing, just like regular expressions. So I've got a URL here for Regular Expression Quick Guide. You might want to print this out so that you can look at it even while you're watching this lecture, because it's a little programming language, except that it's character-based, not line-based, and not keyword-based. It has certain active characters that the character means something versus the character represents the character itself. And so the regular expressions is not part of the base Python, but it's distributed with Python. So you have to put an import RE at the top to say that's really saying pull in the regular expression library. And there is a couple of functions inside that, re.search, which is kind of like a really smart version of the find method inside of strings, and re.findAll, which is kind of like taking and stamping your way through a loop, through a string, and finding all of the things that match a particular pattern and then extracting those. And we'll talk about both of these in this lecture. So here's a really simple piece of code. where I'm just going to sort of show you sort of before and after. So here's a thing where we're looking for lines that begin with from colon.